Hey, it's great. How we doing, everybody? So, we're starting 2-2 today, conditional statements. You should be watching this on Thursday. Yesterday, we talked about inductive reasoning and some of that stuff, talking about the different like patterns and arithmetic and geometric sequences and things like that. Today, we're talking about conditional statements. Now, this is going to be different. All right, this is not like the normal math you've seen before. In this lesson, there won't be any really like math numbers. It's going to be a lot of like logic and reasoning and things like that. All right, so we're going to get into it. We're going to skip this first page. We're just going to talk about recognizing conditional statements. That's 1. Writing converses 2, inverses 3, and contrapositives 4. So we're talking about those 4 things today. Those are our big 4 takeaways for today. All right. So jumping into the first page, we can kind of break up these words or these statements. All right. These are what we call conditional statements, kind of the if then. When we think of conditional statements, we should be thinking if ... then ... All right, so that's kind of those statements. So we can see the first couple here. If the weather is nice, we will go swimming. Then we will go swimming. If I ride my bike to softball practice, then I will get there on time. Okay. Now, in each if and then statement, there is a conclusion. Okay. It's we can break that into a hypothesis and a conclusion. So first, this conclusion part, it's kind of like the result, right? If something is happening, then the conclusion happens, right? If the weather is nice, we will go swimming. So the conclusion is we will go swimming. If I ride my bike to softball practice, then I will get there on time, right? It's the effect. It's the cause and effect type. So if I ride my bike to softball practice, the conclusion is I will get there on time. Okay. So that's our conclusion. The hypothesis is kind of the first part, right? So if the weather is nice, if it is, then the concluding part will happen. Okay. Off of conditional statements, right? That if then statement, we have something called a converse. So our first word we learned, conditional statement, that's if then. Second word, converse. All right. So definition of the converse is something that's opposite, right? So word source, the prefix con, C-O-N, means together, and vertere, the Latin word, which means to turn. All right. So a converse involves changing the order of more than one thing. So for example, the converse of hot is cold. The converse of pass is fail, right? Things like that. So we're going to use this converse with conditional statements. So if we look down here to number 3, we're going to write the converse of each statement. So the original conditional statement, if then, it says, if I study, then I pass the geometry test. The converse would be, if I pass the geometry test, then I study, right? The statement, if I am happy, then I laugh. If I laugh, then I'm happy. That's the converse. Right? The opposites. And our last one statement, you can try this one on your own, pause it and see if you get it. If I have a summer job, then I can buy a new bicycle. If I can buy a new bicycle, then I have a summer job. If I buy a bike, then I have a job. Right? All right. So conditional statements, if then. Converse statement is kind of like the opposite, right? It changes the order. If I study, then I pass. If I pass, then I study. Okay. So you can describe some of these mathematical relationships with an if then statement. Okay, so let's go to the next page and we're going to be talking about these. Okay, this conditional statement, if then. If P, the hypothesis, right? Well, what I mentioned earlier, if P happens, then the conclusion happens. All right, so a lot of times this is represented within a Venn diagram, right? If P happens, it is a part of Q, right? So another example of a Venn diagram like this could be if right? Say if something is a vegetable, then it is food, right? If something is a banana, then it is fruit, right? So we can classify that a little bit, all right? So for example, number 6, if P were to be equal to tears and Q is sadness, well, if our hypothesis is tears, if we have tears, if I have tears, then Q is sadness. I am sad. If I have tears, then I am sad. Right? So again, these are these conditional statements, all right, comparing things. So let's try this problem. Let's just break it up. Let's talk about the hypothesis and the conclusion, right? If a number is even, then it is divisible by 2. What's the hypothesis? What's the conclusion? Well, the number is even. That's the hypothesis. The conclusion, it's divisible by 2. Perfect. Okay. Now let's practice writing the conditional statement. Okay. So how can you write the following statement as a conditional? Well, adjacent angles share a side. If, so we start every conditional, if angles are adjacent, then what? Then what? If angles are adjacent, then they share a side. Perfect. Okay. So within these, we also have something called a truth value. All right, a truth value. So these apply to conditional statements and converses, as well as a couple other things we're going to talk about. But what it means is something is true if you cannot provide a counterexample. All right. So we talked about this a little bit yesterday with the apple, right? If an apple is green, it is sweet or something like that, right? Well, a counter example is Granny Smith apples are not sweet. So that would negate the truth value, which would make it false, right? So basically, you're looking for something to counteract the statement. Okay, so we can talk about these right here. Here's a couple examples. If the conditional, or is the conditional true or false? If it is false, then find a counterexample. So, for example, letter A. If you live in Miami, then you live in Florida. Well, that's true, right? Because if you live in Miami, Miami is a city in the state of Florida, so it means you're in Florida. Just like if you live in Buffalo, you live in the United States of America, right? Letter B, if a number is divisible by 5, then it is odd. That's false. What's a counterexample to that, right? What can we use to prove that it's false? A number is divisible by 5, then it is odd. Well, the number 10, right? That 10 is divisible by 5, but it's even. Perfect. So we can use this negation or this counterexample, okay? Now, here's the other two words. So far we've done conditional and converse, right? An if-then statement. We also have something called an inverse and contrapositive. Now, these are very similar. They're still in the if-then format. However, we use the words no or not, okay? So they negate it. They're the opposite, all right? So let's just go through these. Let's just kind of list examples. This is the best way to learn. The conditional statement. If angle A measures 98, then angle A is obtuse. Okay, this makes sense. The converse, if angle A is obtuse, then angle A is 98 degrees. All right, that's the converse. We just flip the order. If A measures 98, then A is obtuse is our conditional. The converse is A is obtuse, then A is 98 degrees. The inverse, if angle A isn't 98 degrees, then angle A is not obtuse. All right, and a contrapositive. This is Inverse and contrapositive have the same relationship as a conditional and converse relationship. Okay, basically it just flips the order. So contrapositive, if angle A isn't obtuse, then angle A isn't 98 degrees. Now, something to make note here is that a conditional statement and a contrapositive statement are always going to be together. They're kind of paired together, or excuse me, not a converse. A conditional statement and a contrapositive statement are always kind of paired together. If a conditional statement is true, the contrapositive statement is true every single time, okay? And if a converse statement is false, then the inverse statement is automatically false. So they're kind of paired together like that, okay? So that's what we call equivalent statements. So we can see below, we talk about equivalent statements here. All right, and like I mentioned, conditional statements, contrapositive statements, they're always true together, just like converse and inverse statements are also always paired together, if that makes sense. Okay, so last problem we're going to do together is we're just going to go through all four here. Okay, so we want to find the converse, the inverse, and the contrapositive of the conditional statement below. After we do that, we're going to say if they're true or false, and if they're false, we're going to give a counterexample. Okay, so first one, converse. If a figure is a rectangle, then it is a parallelogram. So we flip that. I'm shortening it so I can fit it on the board, but it should say if a figure is a parallelogram, then it is a rectangle. But I'm saying if a parallelogram, then a rectangle. That's the converse. Next, the inverse. So now we get into kind of the negating, right? The inverse would be if not a rectangle, then not a parallelogram. All right. And last one, our contrapositive. Again, we're flipping that inverse. So it would be if not a parallelogram, then not a rectangle. So you will find there's a lot of writing on this lesson, but there we go. The original conditional, if a figure is a rectangle, then it's a parallelogram. Our converse, if it's a parallelogram, then a rectangle. Our inverse, that negating, not a rectangle, not a parallelogram. The contrapositive is the opposite of the inverse, not a parallelogram, not a rectangle. All right, so now we got to say if they're true or false. Whoa. All right, so our original statement, if a figure is a rectangle, then it is a parallelogram. That's true. I'm gonna try a different color. Sorry about that. All right, well, I guess we're just writing big words. Converse, if a parallelogram, if a figure is a parallelogram, then it is a rectangle. That's false. Because an example or a counterexample could be a square. If a figure is not a rectangle, then the figure is not a parallelogram. That's also false. Remember, because according to those truth statements, A converse and an inverse are paired together. So an inverse is also false, and you can do the same thing. It's also because a square. That's our counterexample. And a contrapositive, just like we know from above, our truth values. If a conditional statement is true, so is the contrapositive. Our contrapositive. If a figure is not a parallelogram, then it's not a rectangle. That's true. All right. So I know this is a little bit longer. There's a lot of writing involved with this, but there's not much math. It's just more of that logic and that conductive reasoning and things like that. So what I would like you to do is start on page 14 and then finish your homework through page 16. So a lot of it is the if-then statements or providing counter examples or deducing whether it's true or false or things like that. But pages 14, 15, 16 are your homework. Please let me know if you have questions. Tomorrow on Friday, you're going to be doing more of this stuff. You're going to watch a video to try and help you out understand, or not a video, excuse me. You're going to do a quizzes to help you understand this out a little bit more. And I think it'll really help. All right. So let me know if you have questions. Otherwise, have a great weekend, everybody. All right. We'll see you next week.